force of attraction between all objects with mass. Oops, I lied. It's actually a force of attraction between everything with mass and energy, because photons are massless and gravity still affects them.
We think of it as the reason things fall, but really it is much more. It holds us on Earth, keeps the sun and moon in orbit, and helped create the sun billions of years ago.
Every object with energy attracts all others, so you, your cat, and a black hole in the Andromeda galaxy 2.5 million light years away are all attracted to each other.
Sir Isaac Newton, the founding father of classical physics. His groundbreaking discovery of gravity was said to have happened on a warm summer's day in the 17th century when an apple dropped on his head. His theory consists of
things such as gravity pulls objects towards the Earth. It is what makes planets orbit around the Earth. Newton knew gravity is an acceleration that applies to each mass, which explains why two objects always fall at the same rate. However,
it was Einstein that discovered how it worked and why it happened. Albert Einstein, a young clerk working at a patent office in Switzerland, was pondering amazing concepts that challenged the father of classical physics.
General relativity, hashtag the new gravity. Gravity distorts, curves the shape of space-time. We think of space-time as rigid and stable, but Albert Einstein proposed that space and time are woven together as a fabric, and massive objects can warp space-time, ultimately causing gravity.
Einstein came to think of the three dimensions of space and the single dimension of time as bound together in a single fabric of space-time. It was his hope that by understanding the geometry of this four-dimensional fabric of space-time, that he could simply talk about things moving along surfaces in this space-time fabric.
Like the surface of a trampoline, this unified fabric is warped and stretched by heavy objects like planets and stars. And it's this warping or curving of space-time that creates what we feel as gravity.
A planet like the Earth is kept in orbit not because the sun reaches out and instantaneously grabs hold of it, as in Newton's theory, but simply because it follows curves in the spatial fabric caused by the sun's presence. So, with this new understanding of gravity, let's rerun the cosmic catastrophe. Let's see what happens now
if the sun disappears. The gravitational disturbance that results will form a wave that travels across the spatial fabric in much the same way that a pebble dropped into a pond makes ripples that travel across the surface of the water. So we wouldn't feel a change in our orbit around the sun until this wave reached the Earth. What's more, Einstein calculated that these ripples of gravity travel at exactly the speed of light.
And so, with this new approach, Einstein resolved the conflict with Newton over how fast gravity travels. And more than that, Einstein gave the world a new picture for what the force of gravity actually is. Its warps and curves in the fabric of space and time.
Einstein called this new picture of gravity general relativity. And within a few short years, Albert Einstein became a household name.
Let's think about life without gravity. Imagine all the objects that would float. Well, everything would.
reality, every single thing would drift away in its own direction, leaving behind nothing at all. Without gravity, nothing would remain, but would disappear altogether. If the universe can't curve, no matter or energy can remain.
And in the end, there would be no universe, only darkness.
For all those times when you're bent out and busted, you know no one can be trusted. You're all on your own, and you have no place where you can stay. You're wandering around the same old place, and the people you don't know are getting up all in your face. And well, why don't you leave, get in my bed and we'll get away. You say that I'm lucky, but I'm just willing. You said that I'm a dreamer, but my dreams I'm fulfilling. Whatever that I say I'll do, I promise you I will succeed.